Hey everybody, this is Larry. This is day 28 of the March Leetcode Daily Challenge. Hit the like button, hit the subscribe button, hit me on Discord, let me know what you think about today's poem. Yes, the glasses are back, let me know what you think. And today's poem is Reconstruct Original Digits from English. Yeah, so I usually solve these live, so if it's a little slow, fast forward or watch it on faster speed or something like that. But okay. Given an out of order English representation of, I'll put the digits in. Okay. What does that mean? 5 4 4 5. What? Input only. Okay. Input only contains lowercase English letters and can be transformed. Okay. Okay. I think this problem could be a little bit more specific, but I guess it means that like there's an O and a Y, N and a Y, and a zero in some form and two. Okay. And then the question is, how do you do this, right? I mean, the first thing you can do is just change this to a frequency table and then kind of go through it. One thing to note is that it is always valid. So that means that you don't have to worry about you don't have to worry about like you don't have to worry about certain scenarios. Let's kind of play around with it. Let's have a mapping. So yeah, so frequency table, we just do collections that count of as, and you can think about this as a hash table and just go through that. My thought process is just to spell out the words for a second. So and again, one thing that I might do is just have, depending on how I like to do it, maybe I would have like 0 0 1 1 2 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9, right? Okay, so what does this mean, right? I mean, I assume that there's some way of doing it in a greedy way. For example, because this is always valid, if there's a Z in there, that means that you use all the Z for zeros, right? So you could greedily do that way. And I don't know if there's an easy way to kind of figure out how to, 6 only has X, for example. But then it gets trickier, right? With like 1 and 2 and so forth. So, and I don't know that there's an easy way, because 5, for example, could be anything. Well, okay, let's at least, let me think about this. But yeah, let's just have a map, map string as you go to this. And this is a technique that I mentioned from time to time and more conscious about so that I don't have to do it, is that I can actually just parse this, right? So we could actually, we could split this by comma, and then, we could do for pair in this, and then we return pair dot split of the space, right? So then now we can have mappings as you go to this thing, and if you want to kind of see what this looks like, I'll print it out real quick just to kind of show you. The one-liners do get a little bit messy, and I apologize for that, but it's just about splitting out into for loops, right? So it's 0 to map 1, 1 to 1, and so forth. You can probably map the first one to the number, but I don't think it actually matters, because you return it in a string anyway, and you return the string in ascending order, right? So it doesn't really, yeah. And then the question is, okay. Yeah, this is a little bit weird because now I'm like kind of doing it manually. And what I'm doing is that, okay, we know that, Z, for example, like we were saying earlier, and then there's a U in 4, X in 6, and then, maybe you could eliminate those, right? But then after you eliminate those, are you still able to do it? Well, maybe. So it's a little bit awkward. Because basically, okay, because then now we want to do them in order maybe, and in a greedy order, and then let's do it one by one. So now we can do, we said 6, because there's an x, so we know that for every x, this should be good, right? And then after that, let's see. Let's remove this. I mean, I think we said u. So yeah, so we could do that as well, and maybe we could have an algorithm to do this, to be honest, but I don't know, right? Let's see, and then after that we can do the 5, because 5 have, and maybe we could, you know, do a dependency graph. Yeah, we could have written like a loop or something just to do this in a programmatic way, but I guess now I'm mostly done. So maybe not mostly done, but well, 7 in that case is, you know, after all the 5s, v is unique again, so we can do the 7. And then here, you know, we did 2 for the w. Let's see, 8 for the g. Yeah, and then now 9, I guess, for the 9, but it doesn't matter, 1 for the 1 as well. So that means that, okay, 1, and then 9, and then 3, right? So this is definitely very hacky in a way, but you can kind of do it, you can think about it as a dependency graph where, oh no, not even dependency graph, you just do a while loop, right? You just do a while loop to see like, hey, if I contain any string or contain any character that any other characters don't have, you know, we can use that in the beginning, right? So you could write that, I did it manually, so I don't know. And then now we can do it, yeah, let's get the answer, put it in a way. So for x, for, what's it, digit word in mappings, you know, let's see, there are a couple of ways to do this. Is there a set division? Is there counter division in Python? That would be pretty cool. But yeah. So basically, we will get a frequency of the word. So frequency or character words, I guess. I don't know. Oops. Is equal to collections.counter of the word. And again, this just sets up the frequency map. It is a very easy way to do it in Python. But in any language, even in Python, you could do it with a for loop, right? And then now we get how many, you know, what is the smallest number that has overlaps, right? Because now, yeah, for example, z is the smallest one, so then we are going to be terminated by the z. So I think I worry a little bit about making sure that I am correct. Oh no, because there's always a valid answer. Okay, so that means that, you know, I was worried a little bit about with, like, I mean, I know that I already talked about this, but I sometimes trick myself. Like if there's 5 z's and 1 y, then what do you do, right? Or maybe in a different case, there's only 2 v's and 2 y's, but you need 2 y's to contain you for 7. Well, the thing is, this is always going to be valid, so you don't have to worry about it as long as you do it in the right order. And so as long as we trust that, then we go, okay, min, you know, let's just say min overlap, min count is equal to, let's just say some infinity number, so float of infinity, and then now we go for each key and frequency character, right? For C and frequency character dot keys, min overlap is equal to the min of, well, itself, or the min of frequency character of C, or mappings, no, not mappings, F, the other one, of C, right? So basically this just does counts the number of possible characters there is, and then, well, we append the digit times min overlap. as the answer, but we also want to go through the keys again to so yeah, to kind of subtract that out from the frequency table, because that's how many, basically now we're consuming that many number of characters, right? So now we overlap, and then we just, and this should be maybe good. We should sort it at the end, because now we want to sort it by the digit order. I mean, this is a little bit lazy, but that's fine. You could do bucket sort or whatever, you know, there are some linear time algorithms you want to call it that. But yeah, and then we just join it back into a string. Let's give it a go. Is this roughly okay? So that looks good. Yeah, so I'm gonna give it a submit and hope it's okay. A little bit lazy today on the edge cases. Oh no. Why do I get that wrong though? That's odd. Actually, I don't expect that. Keys. So this should be 2. Because I don't convert it to int in any way, so that's actually unexpected. Unless I did something silly, which is possible. I've been very silly lately. Seems like this is just returning 1. Oh, this is wrong. This is this is very wrong. I actually was thinking about this. Oh yeah, I miswrote this one. So basically, this calculates. I need to write this a different way. I think I said this wrong. I set this up incorrectly. But basically, what I want is that, okay, for example, if there are like 8 z's, we should set this to z or z's, right? 8 of them and not 1. I don't know why I did it this way. Now that I think about it. But the idea of the algorithm is correct, but my implementation is very bad. Maybe it's just today. Today I feel like I've been okay, except for my implementation. It's just been all over the place. Let's think about how I want to do this, right? Yeah. I think what I want is actually this. Yeah. I think I'm just having a, I don't know. Everyone's gonna have one of these days, and hopefully that makes sense. But yeah, I don't know why I did it the other way. I think I was thinking of something similar, and I kind of skipped over it because I was going too fast. I need to slow down. That's one of my problems that I've been going lately, is that I've been having too many problems in my head, and like I just speed too fast. I go by too fast without really thinking about what I'm doing. But yeah, so this looks good now. I should have tested that case, I guess. But yeah, but basically that's what I wanted to do. Min overlap is just a count of like the you know, like basically if you have the word 0, how many times can it show up in the frequency map the most, right? And one of those characters is going to be Z's. So this is why this works, I think. I could be wrong. Let's give it a submit before I talk a little bit more. Okay, cool. Yeah, so it's always going to be constrained by the Z, and because it is always valid, we don't have to worry about additional checking or even make decisions, because you know, if there's 5, like I said earlier, if there's 5 Z's in S, then we know there's going to be 5 zeros no matter what, and we just have to subtract the other ones. And that means that by definition, there will be at least 5 E's, at least 5 R's. Maybe R is unique actually, but at least 5 O's as well, because if there are more O's, they just go to other characters. So we definitely abuse the fact that the input is always valid. So yeah, so what is the complexity of this? This is just going to be linear time, because for each character in the string, we put in a frequency map, so this takes linear time. And then here, you can actually pre-cache this, of course, the mappings table and the frequency character of the map. And of course, these overlaps calculation will at most be O of alpha, where alpha is the number of characters or number of characters in the alphabet, which is 26, which is constant time if you want, or O of alpha if you prefer. So yeah, and this is, of course, this is just 10 digits. So it's going to be a lot of, so it's just the number of digits times the number of alphabet, and then plus a linear time for creating this frequency table. In terms of, and I guess this is, like I said, I did it the lazy way with sorting, but there's only 10 elements. So you could say it's, 10 log 10 or digits times digits times log digit or 1, depending on how you want to phrase it. It's all, as long as you're consistent with your reasoning and logic, it's fine. In terms of space, this is O of 1, because this, or O of alpha, depending on, how you want to call it. This is constant. This is, or all of them with digits if you like. I don't know. Yeah. What else was I going to say? Yeah, and then the answer is just going to be linear in the size of the output, which you cannot do better. I guess you can do it in place, but in Python that's not really friendly for strings. But yeah, so roughly speaking, this is all linear time. Let me know what you think. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think, and hope you have a good day. Hope you have a good rest of the weekend, and yeah, have a stay good, stay healthy, and good mental health. I'll see you the next day. Bye bye.